Welcome. Today, we are going to learn how to find the inverse of a matrix, or the matrix reciprocal. Last time we learned about the determinant, and that the determinant determines on whether there is an invert or an inversion of the matrix, or an invertible matrix is what they say, if the matrix is invertible. As a quick review, if I have a 2 by 2 matrix, because we're only going to do 2 by 2 to keep things simple, a 2 by 2 matrix, its determinant is found by taking the first element times, I like to think of it as the last element, or A times D minus B times C. So I do the diagonal from top left to bottom right minus the diagonal multiplied together from top right to bottom left. And then if that determinant, if that number comes out to be a non-zero, our matrix is invertible, or it has an inverse, or a reciprocal, okay? And the way we calculate it is this. I take that determinant, that number, and I do its reciprocal, or its inverse. In other words, I take the reciprocal of the determinant and use it as a scalar to multiply back into a matrix. And the matrix uses the same four numbers, except we've moved two of them and changed the sign on two of them. The two we move are the A and the D. We swap their positions. So I move A down to the bottom right, and I move the D that was in the bottom right back up to where the A was in the top left. The B and the C, I leave them where they're at, but I change their sign. Once I've done that, I distribute this. This will be a scalar. It's just a fraction or a number. I distribute it in and multiply each of these four terms by this reciprocal of the determinant. Again, another way to write it, if you don't like the DET for determinant, you can write it as 1 over AD minus BC from our original matrix times where I've swapped the position of the A and the D, and I've changed the sign on the B and the C. Now that might seem a little confusing, but it's actually not very difficult. Let's actually do one or two of these, because I'm going to assign number 12, the inverse of a 2 by 2 matrix. And they start out very, very simple, because they start out with a diagonal being 0. So the first thing I do is on a piece of paper, I'm going to write down that matrix. -1, 0, 5, 0, and 5. And the first thing I'm going to do is now determine the determinant, which is equal to A, which is -1, times D, which is 5. Again, if you need to look back up here, A times D, minus the B, which is 0, times the C, which is also 0. That gives me the determinant is -1 times 5 is -5 minus 0, or just -5. So my determinant is -5. Since my determinant is -5, or a non-zero number, this matrix will have an inverse. And the way I find the inverse is I take the reciprocal of this. So I'm going to do -1 over 5, and I'm going to distribute it in, because that's a scalar. I'm going to distribute it in to a matrix where I swap the position of these two. So that means I'm going to take the -1 and put it down here in the bottom right. I'm going to take the number that was in the bottom right, move it up to the top left to 5. And these two numbers, I'm going to change the sign. Now, since they are 0, when you change the sign on 0, it doesn't change it. So I'm just going to leave them as 0. I didn't swap their position. I just changed their sign, which did nothing. Then the last thing I'm going to do is distribute in this -1/5. So I do -1/5 times 5. That's going to be a -1. I'm going to do -1/5 times 0, which is 0. I'm going to do a -1/5 times 0, which is 0. And I'm going to do a -1/5 times a -1, which will become a +1/5. And yes, you will get many, many fractions when you're finding the inverse of invertible matrices. Now, on our iExcel over here, you notice it gives you the option to do a 3 by 3, a 4 by 4. Your inverse of a matrix will be the exact same size. And from the last lesson, remember, the only matrices that have inverses or that are invertible are square matrix. So a 2 by 2, a 3 by 3. But since this is a 2 by 2, your solution will be a 2 by 2. And now I'm just going to type in these four numbers. So I'm going to type in -1. And yes, you must type in 0. It is a number. Don't leave it blank. Type in 0 and then type in our 1/5. Again, it gives you the option to do a fraction key. So I go 1/5. And then I hit submit. Now that one was fairly simple because the diagonals were 0. Again, the diagonals are 0. I'm going to jump ahead so you can see one where, like, we might have one that isn't diagonal. Or I'm even going to go further ahead, see if I can get, like 4. But the process is still exactly the same. What I'm going to do is I'm going to take this matrix that's 4, 3, 8, 6, and the first thing I'm going to do is find the determinant, which is A4 times D, which is 6, minus B, which is 3, times C, which is 8. So my determinant is equal to 24 minus, 24. I really like that. If this is 0, if the determinant is 0, it has no inverse. It's undefined. I can just come over here without any more work, hit undefined, and hit submit. And I get my answer. Let's do one more where it's not undefined, though. Again, they're throwing a lot of zeros in there. I just wanted to show one that had 4 numbers that's not a 0. And they just like to keep one element. I guess they're just trying to always keep it simple for you. So maybe we'll do one that has that 1 0. So we'll do this one. It's perfectly fine. So what I'm going to do is I'm going to, again, take the matrix they give me, 4, 6, 0, and -3. And I'm going to find the determinant first, which is equal to the A value, 4, times the D value, which is -3, minus off the B value, which is 6, times the C value, which is 0. And that's why they keep throwing in a 0. It makes the determinant always a value because you're going to be minus and 0. My determinant then is a -12 minus 0, or just -12. Since that's a non-zero number, this matrix does have an inverse. And again, the way we find that inverse is we take the reciprocal of our determinant. So yes, I'm going to take 1 over -12. That's the reciprocal of that. And I'm going to multiply it into another 2 by 2 matrix where I take these 4 elements and I adjust them a little bit. I'm going to switch the position of A and D. So that top left 4 is going to go down to the bottom right. The bottom left or bottom right number of -3 is going to go up to the top left, -3. And then I'm going to change the sign on the 6 and this number here, 0, which doesn't do anything. But if it was a number, I'd change its sign. So I don't move them. I don't move these two. I just change their sign. I'm even going to put a little -0 there just so you know I changed its sign. Doesn't have any effect, but I put it there. Now I'm going to distribute in. So I have that -3 times the -112, which gives me that first element is a positive 1/4. And yes, by all means, reduce. 3 over 12 is 1/4, and the negatives make it positive. -6 times a -1/12 is going to be a positive 1/2. 0 times any number is 0. And then -112 times 4 will be a -1/3. And there is my inverse of that matrix. So again, I come over here, type in 1/4. So again, I use my fraction key, 1/4. Second term is also a fraction. It's 1/2. Third term is 0, which makes the work a little easier. And the last term is also a fraction of a negative 1/3. So negative 1/3. Make sure I put them all in right. I got the 1/4, the 1/2, the 0, the negative 1/3, and I hit submit. And great job. If you have any questions, please email me or log on at 1 o'clock. Well, tomorrow's Friday. Well, it might not be when you watch this, but log on at 1 o'clock on a weekday or email me to set up something for either earlier in the day or for a Friday.